All right. After a very tiring and frustrating process, I was able to make this work. For everyone, uh, I'm really sorry for all this hassle and cancel and then again. And the moment I was hoping that everything was going to be all right, now uh, we had an issue with the stream. I don't know why it refused to work as usual. So at least we are live, and the video will be available also on YouTube. I'm going to clean it up, and I'm going to have um, the video tuned, and I'm going to post it in our group so everyone will be able to see this presentation, this workshop. That's, that's really interesting, and that was the most frustrating thing for me because this presentation really makes things move. So let me share now again, finally, my screen. Let me move this here, and I'm going to share the big screen here. I'm going to allow audio as well. And here we are. Yes, here we are into our Azure. Okay. So what we have here, this is a deployment that goes and follows the traditional path of deploying web applications as containers. The most important parts here are the containerization process, but also the breaking changes that have been introduced from May onwards, which in reality, and in a few words, it is it has changed the way that we are communicating with Azure AI Foundry and our agents. So I have a process here that I have already started deploying. We're going to need a storage account. We're going to need a Cosmos DB, and we're going to have Azure Key Vault to handle our secrets. Let's go back to Azure and continue creating our resources. So let's see what we have here. We have a resource group. We have followed the standard process of creating Azure AI agents, something that you can find in the documentation. If you go and click Azure AI agent service, you will see and you will understand from the Microsoft links how easy it is to start with this. Okay, because there is a quick start here that allows you to understand how things go. But the most important thing is the environment setup. Microsoft offers us two ways to do this. The first way is to follow the basic agent setup. That's just creating a project within Azure AI Foundry. And the standard agent setup, that is a more enterprise way of deploying your agents. It uses managed identity for authentication, and it has also GPT-4o model deployed for us. It has Cosmos DB and storage account, as well as AI search for embeddings and in case you want to work with your own data. So this is what exactly we have built. It's already built for us. And now we want to build on top of this our own solution. Okay. So we need also this container registry. Let me see what we have here. where we're going to build and deploy our images. The environment is mostly set up as you understood. Okay, here is the resource group, the key vault, the default key vault, and the AI search, the managed identity, the Foundry service. What we need to do is continue creating our resources, and then we're going to explore our way of interacting with the agents, how we build our client, how we create agents, how we keep the same agents in case we want to stop our application and come back later, and how we keep everything tidy. Okay, so let's see here. There is this script which I haven't tested, but that's okay. I am already key vault administrator, meaning that I am allowed to create secrets and all that stuff. I have created already the storage account and I need the uploads container. So let's go and create our uploads container in our newly created storage account. Here it is. And it's going to be created very, very fast. Now, we have also the need to create the Cosmos DB, but the Cosmos DB is already created for us. We're going to need to create a database where we can name it documents DB. I don't know if it's already there. Let me have a quick look. Yes, the Cosmos DB is missing, so let's go and create the Cosmos DB. It is used to save our documents. What this application does is having 3 agents work in parallel, and one of them is a regular chat, another one is um, a document summarizer, another one is a document formatter, let's say, and those agents take our document, our text, summarize it, and resave it with a new title and a new summary in Azure Cosmos DB. It can really touch at the enterprise levels of document management, especially for translation. If you throw a translation agent there, you have created an enterprise network management solution. I'm following the default setup and I'm going to create it. Something I forgot here, probably the name, of course. And that's it. Review and create. We have already our AI service and we will start to create now our secrets. First secret is going to be the storage account name. We have the need to create the Cosmos DB connection string, AI project endpoint, and then we're going to assign RBAC roles for our managed identity or for our users. So we're going to see that how that goes. Very nice. So let me have a look here to show you how we're initializing our client. So here it is. We're initializing our client with Key Vault, and from Key Vault, we're getting all of our secrets in order to be able to connect to AI Foundry, create the agent, and if exists, don't create another one. Assign them the required tools, provide them the required prompts or system prompts to say it better, and here it is. This is the first agent who's going to be the title agent. So we are also creating titles. We have the chat agent, the document processing, the extract text, the storage agent, the summarization agent, and the title agent. So there are not uh, just two, there are more. All right. So let's see. Let's make this fast. So I have taken so much time from you. I know that. But now that I'm here, allow me to run this. So we have our Docker file for the backend, very simple. We're exposing 5000 port, and then we have the backend, the Docker file for our front end. Front end is our React application that follows two stages. The build stage that builds the application and running npm install, meaning it downloads all packages needed, it builds, right? And then the exposure stage, the serve stage. We're using engines that it is a reverse proxy that allows us to expose applications, ports, and APIs to the outside world, or to, in general, just expose. Okay, it takes care of exposure. Doesn't have to be necessarily internet, right? You can use Nginx also for internal communications. Let's have a look on our variables, which is very important to understand what we need. So the keyword name is a variable that the backend calls because everything is stored in keyword. So let's have a quick look. What are the variables needed for this backend to work? We will do what we just did. We will check all the secrets needed. So the first secret is the AI project endpoint. Project endpoint. Get secret AI project endpoint. Let me copy and let's go back to our key vault and create it while Cosmos DB is built. Cosmos DB is used for storing all the information around the saved documentation, saved documents, sorry, and also it's used as a pointer, right? It's going to show us where our documents are stored in our storage account, and it will create a nice visual, a nice informational table of where everything is. Secrets. Let me create the first secret. It doesn't like that. Yeah, I know. AI project endpoint. I will correct that in our backend. So let's find our Foundry. And this is our project endpoint. We copy this one. It's setting the variable right in its own name, but for the key vault name, we have used something that is acceptable in key vault. So this is for initializing the AI. What other variables we have here? Get secret. Okay, so this is what we're looking for. The get secret for our secrets. So it is storage account name and Cosmos DB connection string. Let's add these secrets in Key Vault. Of course, you can do that via automation and save much time, very uh, substantial amount of time. But we're doing this to see everything, like an X-ray, how this thing works, and in general, how projects work in Azure. And of course, we're following best practices. That's why we're taking our time. If you understand what I'm saying, right? AI service. So this is the one. Storage account name. That's why you have to be careful not to make a mistake. Nice. Then we need the Cosmos connection string. Cosmos is here and it is created. Let's create also our documents DB to be ready. It's a database. Okay, let me remember here. Storage account, and then we are going to create the container Cosmos DB. Yes, database and container. And the container is going to be files. So we need the database name documents.db, document or documents. Let me see, documents db. Okay, and within this database, we can create a new container. Existing container is files, and the partition ID ID is ID, if I remember correctly. Yes, ID. This is the one. This is how Cosmos DB understands which container deals with what IDs. It's a way of indexing. Okay, so we have our documents DB. Let's get the connection string. This is the primary connection string. Let me get it. We need it for our storage. Yes, the Cosmos DB connection string, which we're going to change the name. So in key vault, in our own key vault, a new secret. Let me paste the secret and Cosmos. That's fine. Create. Return here. Okay. This is already using the connection string. So what we need is to understand where the client is created. This is the one that I must change. Here is the client created for Cosmos, right? All right, documents DB. Okay, now we need to make a change in our storage account and authenticate with Enter ID. And you can do this by going here, configuration, default storage account. Let me remember. I always forget this. How I have to do it. No, it's not that. Yeah, and Azure also as a contributor. Yes, I do have this role. Anyway, I think we can bypass this because we're going to use managed identity. Let's leave it to containers for now. Okay, I'm sorry. Switch to access and yes, here it is. Mm, yes, of course. Anonymous access is disabled. Let me enable anonymous access and then we will deal with authentication. Okay, for blobs. No, no, containers, I'm sorry. Okay, great. The uploads container, we had changed the access level. Let me do it on this level. Yes, this is the correct way. So for the uploads container, we change the access level to anonymous read access. Let's move on. Okay, we have our key vault. And now we need to build our images. So let's see if I'm missing something. Let's have a quick look here and understand if there is anything else we need for our Key Vault client connectivity and secrets retrieval and creation. Yes, the backend will need to authenticate to the services in order to write data. That's the case. Okay. Yes, I believe we're fine here. This is for Azure Developer CLI, not needed. So let's go make the save. CD to the backend. And let's build. I think we can build directly. Build the registry. No, we should log in first. Let's log in to be sure we are authenticated. And RGBY service. RGAI service. Okay. What we're doing now, you can see here from the code. I'm sorry. We are we're logging into the container registry that is within this resource group. So this is a smart way to do it, not needing to find the name of your container registry. You're putting a parenthesis and the dollar sign, so you're actually naming by listing the container registry. A very smart way to do it. And you can do it all around just using your resource group and nothing else to log in or get information from other resources using Azure CLI. You don't need to know the names or list them. You are just going to call them from this um, from this point. Why? Because it is stuck in there. Okay. Now let's build our backend. HTTCR build. Again, the registry, you can do it with the same way. And the image, you can name it backend and add a dot at space and dot at the end. So you're saying build my image in this container registry. And by build, what we mean? This is very important to understand that what Dockerfile does. Let's see what line by line from node 20. So what's happening here? It is downloading node 20. It's getting the image of node. It's creating an environment, and within this environment, that's why it's called container. It is not a virtual machine. It is not a hypervisor. It's something between these things. It lives in the place between the operating system, the hardware resources, and the software abstraction level. Containers are very smart. So we're getting a Linux image, okay, of Node, Like imagine like a virtual machine, like we're calling on demand a virtual machine. A very small virtual machine, however, doesn't need something to run. It's the running directly as a node image. So that's what Docker does. Very, very smart and flexible. So we're getting the image and we're building, Docker does this for us, within this container, a directory structure. So we're creating the work dir, which is stage to node, where is your directory to get and work your code. And then it copies one important file, package.json. In JavaScript, package.json is the package where it announces which packages are installed and needed. Let's say that we need to create PDF files. In order to do that, you need a special library in Python or a package in JavaScript. It's not everything there. Okay, some packages need to be downloaded. Okay, remember what we do with Ubuntu if we want to install a program. We run apt-get. It's a very similar process. So in package, we're declaring the important and the needed packages in order for our application to run. So we're copying this within our container. And then we're running npm install. npm install will look into this file and start installing all the packages that are referenced there. And then it copies everything else from these dots you can see into the work dir. And finally, it is exposing port 5000 and it is running the server. This is how a backend is created in the process of containerization. Now, this is a portable image. In my PC, when I do this and I run it, because I haven't run it, I have just built it, I will find, with the help of Docker Desktop, some images living into my computer. Here they are, some of them. I can run them and, interact with them, either as a frontend or a backend or an application or whatever. They are their own life cycles. They have their own soul, their own build, their own um, um, opera, operability. Huh? They have their own operability within your PC. It doesn't matter if it is Windows or Linux. It is Docker. And that's why it is very smart and everyone is crazy about containers. This is the future, unless we see something else. But for now, I think that's the future. Okay, and now we have built our image. But this very smart command, it is not just building it, it is also building it into Azure Container Registry. If we use Docker commands, we need three commands to do this. We need to build, we need to tag, and then we need to push the image to the container registry from our PC to the container registry. This command of Azure, coming from Azure Container Registry, it is used to build the image directly in your registry. So it's pushing already. You need your Docker file in the root level of your application. Otherwise, it will fail. It's going to pack everything, it's going to install everything, and it's going to be ready to be pulled and run. It doesn't mean that if I push it now this process doesn't mean that it is running, okay? It is prepared, and once someone builds it and pulls it, it will run it with this parameter. So let's see what's happening. This is our container registry, and this is where you will find your images. Give it some time. I hope I have called the correct. I'm sorry, the correct resource group. Yes, we're waiting. So that's the beauty of Docker and containerization. I can run my image wherever Docker is supported. That's it. Whether it's Kubernetes, container registry, container apps, uh, container instances, everywhere. Everywhere there is support for containers. And this portability makes the difference. Okay. All right. Let's give it some time. And that's it. Let's go to the container registry in the repos. And here it is. It's created a repository with the name of our image. And this is something also important, tags. Imagine we're not sure about our image. We want to make changes, especially in front ends where things are a little bit more complicated. You have two stages. You have the build and the serve stage, or you have a reverse proxy where you want to make some additional utilization of the capabilities of your reverse proxy, like caching or redirections or whatever. Uh, you may fall into the trap of overwriting or destroying your image with bad code. So the tag allows you to have multiple versions of your images, and you can keep your latest or your prod or your healthy, you can give tag untouched, and then start creating the upgrade one or version one or V2 or whatever. Okay, this is best practices. And what is this thing at the end of the day? Just for reference, we're going to say that a Docker image or a Docker container, it's a bunch of broken down code non-readable by humans. This is it. Do you understand anything here? Do you really understand anything at all? No. It's only for Docker to understand it. So if we pull the image, I can pull it from another PC. I will get my backend there. Let's do the same with our frontend. It's a little bit more interesting, right? Because the frontend has the visualizations. It's actually something that you can see. The backend is something that you only can call. Let's go. Let's go to the frontend. This is some testing. Not needed anymore. CD. Let's move back. What? No, this is wrong. Yes, this is the correct frontend. And again, the web user interface. So let's have a quick look in our frontend to see what's the case here. Frontend. This frontend is a very basic JSX, means usually React, JavaScript, that types of applications. Mostly React and Byte also. This is a React and Byte web app. It's very powerful. It is enterprise level, and I believe 80% of our websites all around the internet could be a flavor of React or Byte or something very similar. I'm sorry. Let me show you how we can see our frontend. This command, the npm run dev, it's a command that if our frontend is healthy and it doesn't heavily rely on the backend to run, you and we are able to see it, to see what we have created. what we have created here. Let's have a quick look. Yes, this is our front end. Very simple, but yet nice. You can see here we have these buttons, home and documents. Documents, we're taken to another page where we can explore what Cosmos DB stored, translations or documents or whatever is stored there from us. And here we can have a very nice chat interface with our agent. And we have also a nice hidden keyword that when we write it, I don't know if it will work. Yes, it doesn't work. I don't remember the keyword, however. We will find it, don't worry. It presents here a nice upload menu in order to upload your document. Just a moment, please. Give me a moment. Sorry. Thank you. So, a React JS application has this structure. The SRC folder is the most important folder, right? It holds all the pages, all the constructs, all the visuals, everything around what you see, what you build in most um, enhanced or uplifted applications. There are a lot of pages here. Every little detail is coded and it is accounted and it is related to other things. It's very fragile, especially for people that start now. My suggestion is go break some eggs with React. You're going to love it at the end of the day. It's going to get you frustrated, and then you're going to love it because for me at least, it's the most wonderful thing to have absolutely no idea what is coding, a front end and full stack, and every developer's lexicon and dictionary, and finally be able to create something out of your nothingness. Because I'm not a developer, but I really enjoy creating the solutions, and I'm always happy to see something living, like a visual, like a nice web user interface, like whatever. I'm trying to find the keyword. I will find it that allows us to present this hidden uh, upload document menu. Input is the message. Okay, upload. Yes, it is correct. I'm not sure if we need also the double dots here. Let's see. Yes, you see what happened? If I write this keyword, upload, and the marks here, the two dots. React presents me with a hidden menu where I can choose and upload the file to my agents. That's a very nice thing. And actually, it's, how can I say? It's a smiley face, something like that. A hidden, keyword where you uh, show something that is not there, but it can be there if you write the correct keyword. Okay. Okay. And then we proceed to communicate with our agents. You see here this Vite API URL. Vite or React need this type of syntax. This is the one, import meta.env Vite API key or whatever. Everything should start with Vite as environment variables. It is very different from the backend that we saw earlier. Backend doesn't care. If you say to the backend, okay, here is your environment variable, you will get it from the environment, just like the key vault name. When we are going to host our application, actually run it, we can deploy there an environment variable. Whether it is web apps or Azure Container Apps, you have the capability to uh, generate an environment variable. The backend will find it if you have the correct name, of course, right? It's not the same with Vite or React. You need a way either to pass dynamically the resource URLs that you are creating. That's something very hard. There is a blog about it in my site, how you can do it dynamically, or you need to be a little bit patient, build your application, and then go back and change the environment variables once you know the other resources names. For example, when you create a dynamic backend, you don't know the name. Of course, if you're using your own domain, then you know the name and it's much easier. And all the environment variables should be stored in this .env file. Another also good practice is to pass these variables within Docker. So your app is something between. It's in a hybrid mode of getting the environment variables. Still, you need them in the final stage when you're going to run your application. Okay. So either you do it through environment variables directly on your code, which is not a good practice to hard code secrets or keys, or you pass them through Docker, or there are also some other methods that you can do it without exposing, at the end of the day, your secrets. Let's try to build this application. Okay, I'm going to stop it, and then we are going to start wondering why it doesn't work. So, AZHR, again, build. We don't need to log in again. We have already logged in. This time, let's put the name web UI for our front-end image. It's going to take a little bit more time, and we need the API secret, which I have to go and find it. Luckily, I have already created the API management instance, and someone will ask why you did that, why you did everything. Because it's a very nice example of how to communicate a lot of endpoints through a central API service, and that is API management instance in Azure. Let me find it. Here it is. So API management instance is your API hub where you can manage, host, secure, and govern your APIs, your endpoints. It has gone a long way to be this amazing product. It's really amazing. And you can really host anything here from language models, WebSockets, GraphQL, anything at all. Okay. Even Azure AI Foundry. This is amazing. App service, container apps, and all the stuff. We're going to use app service for our case. But before that, I need to authenticate through my key. And I need to remember how to do it. Service. Yeah, and I think this is the one. This is the all access. Product starter, product unlimited. Yes, API management offers you this capability to create products and separate different APIs to different levels of control and sensitivity, let's say, based on what is exposing this API. In our case, yeah, it's not that important, so the all-around key won't hurt. I think the name of the API is correct. Yes. And let's build it in our registry. And in the meantime, let me show you something really, really amazing. Watch. It says to upgrade in premium, but I'm not sure that that's the case. Let me see what type of service. There are tiers, of course, in Azure Container Registry, and each tier has different capabilities. For example, this one, I think it's the basic tier. Let me see. Okay, it's the standard. It should be able to create the artifact. Hmm, they changed it, right? Okay, now deploy to web application. Yes, of course, you need admin. What I did, let me explain. This is a standard tier container registry. Okay, there are three tiers: basic, standard, and premium. Different capabilities to different tiers, even private connectivity to your registry, which is very welcome when you want to protect your images at any cost. So nothing can touch them. What I did, I went here to access keys and I enabled admin user, meaning that I can authenticate to my registry using a username and password. And these are the passwords and the username, not just by AZ login, but also by AZ ACR login or Docker login. I'm sorry, Docker login is the correct one. And it is needed when you want to do this. And this is something very nice and cool. You go to the registry, you find the image and the latest tag or your tag, and from here you can directly deploy to Azure Web Apps. And this is amazing. And let's say that this is API, API web AG 0001. Okay, very. I can select the plan for my web app. I'm going to get one like ISPHN 001, sorry, 0101 in North Europe. This is the infrastructure, right? The server where my web app is running, the virtual server. Operating system Linux and create. So I'm creating directly a web application from my pushed Docker image. It's not only about containers. Azure Web Apps supports the capability of containers to be published, exposed, and created from Azure Container Registry. So if you don't want to work with Kubernetes or Azure Container Apps for any reason, you still can have containers and containerization and work with your Azure Web Apps, right? Very cool. And you will see later how easy it is to manage it and switch from one tag to another if needed and all that nice stuff. I have a feeling that this failed and I knew it. A build doesn't exist. Build doesn't exist. Yes, this is. What? Why it doesn't exist? I'm a little bit curious here why this is happening. Let me understand a little bit more. Okay, okay. Copy from file does not exist. Okay, let me find another Docker file. I cannot understand what's the problem here, so allow me to search around. Probably there is some syntax error, probably. Let's see. We are doing troubleshooting, that's not a problem. It's nice to do this. Yeah, we need also this. Oh, from builder. And it's up dist, yes. Yes, probably this is the problem. Copy two dots npm run build. Yeah, something is not right here. Okay, so let me find this. Okay, work there. It's the application. Run npm. Okay, the dependencies. Copy the source code and then build the application. Copy the source code and then build. Okay, I'm going to ask our friend here. Give a moment. I'm going to get a suggestion from my chat here. Yes. And the error is this one. I don't know why this Docker file is messed up. It shouldn't. Yes, correct. It's the dist. Let's do it correctly. You can see here that we have a dist folder, not an app. Probably this is the issue. Let's save, return to our web user interface, and rebuild our image. Okay, it is proceeding. Yes, errors will be there, either from not updated packages up to deprecated uh, libraries and packages as well, to no secure, everything. And this time it was successful. Nice. Our uh, backend is deployed as a web app, so we can do the same for our friend the front end here. The web user interface is this one, the latest tag is this one, deploy the web app, a web North Europe, North Europe, okay. Yeah, let's go. Okay, but this thing will take forever for us to deploy. So I knew that this will happen. The signs were there from the very first day. So I'm going to um, keep the same narrative with agents. We're going to see them again in Azure AI Foundry, this time with another application that's already there. So let's go and see something else that it is happening. In the same manner. We will try with this one. We're not abandoning it, but let's see something interesting rather than just troubleshooting and deploying from scratch. So AI agents have a great amount of flexibility and capabilities. If you you know um, throw into the mix something really amazing like MCP servers, you are getting not just your regular, agents. You're getting something very intelligent. This application that I'm going to show you is deployed in container apps. I'm going to leave from this interface, not needed anymore since we have sent everything to Azure. So allow me to open the AI agents. It's not this one, AI architect. So let's have a look in something really cool. What we have here is this thing. It is an Azure Container Registry, Container Apps environment that is hosting three different applications. Okay. The purpose of these applications are to communicate with each other and provide to us architecture diagrams. I'm actually killing my job here, and I'm killing it softly by providing already the solution for AI to do it. But let's be honest, okay? This is just a helpful application for architects. You will get a nice document based on best practices directly from Azure agents and an architecture diagram, which of course it's not final. It's a good start, but it's not the final. Only someone that has deep expertise, understands the client, the customer, and the needs of the project can depict the architecture in a diagram that someone else will understand. This is very important. But no one will say no to a helpful assistant like this Architect AI application that I have created. This thing does the following. I can write here design. Let me validate something because I'm playing a lot around and hopefully I haven't killed here everything. Agents. I don't remember if it's this one. Yes, this is the one. And let me validate that I'm using the same uh, Azure OpenAI service. As we are exploring containers now, things are a little bit different than web apps, right? The process so far is the same. We have built the image and pushed it to container registry. Instead of pulling it from a web app, this time we pulled it in a container apps environment and actually in a container app. The idea is the same. Everything is uh, saved in Cosmos DB, so you can see save diagrams. Sorry, you can see save diagrams from this. Sorry, where is it? From these saved architectures, there is already something here. Okay, you can see what this thing creates. It gives you all the design principles as best practices and highlights, and also creates a nice architecture diagram to work with. The request here was let's see what was the request in this case. Two Azure SQL servers in different regions that save data in send data to machine learning through Azure functions. The prompts were very, very you know minimal for the sake of testing the application. But if you go a little step further and provide actual powerful prompts, you will get powerful results. It's very important to know this correlation. So let's start exploring what it can do. It will take some time, and then I will explore what MCP is doing in this case. It's very smart. So we are going to say design a web application with DNS load balancing with Azure Traffic Manager that stores user data into Azure SQL and Azure Data Lake for redundancy. While we're writing, there is a validation happening in the background. And the validation is about the agent. It's helping itself. This is a very minimal prompt to tell you the truth, right? If you want to go and create something that an architect will take it and create something, it's not two phrases. You need something to reach here, reach. But let's go with a minimal way. Once I press this button, let's go and see what's happening in the backend. You can see here a lot of environment variables. The best practice here was not to save it, to store the environment variables into the container app. It would be much better to have this in Azure Key Vault. But since this is not an enterprise deployment, it was very easy for me to do it like this. I used environment variables directly on the container apps environment. It's very, very um, easy. It's easier than creating Key Vault and then the Key Vault client, and you have to manage another resource and all that stuff. Let's go and see what's happening in the logs. Something very nice with Azure is that you have very good transparent logging. So here it is. You can see here that we are already calling the suggest architecture, which is the validation that you saw earlier. And it's calling this MCP service, the third container, the third wheel of this solution. What is this third wheel? This MCP thing. And why? This MCP thing, my friends, does what an MCP should do, provides knowledge to our agents, so avoid, I repeat, consuming tokens from Azure AI. Why? Because I have provided to this MCP service all the information needed for someone to create diagrams using Python, because these diagrams are created with the diagrams and GraphViz packages from Python. I will have a blog post very soon explaining all the steps for this thing to make it work. So what happened in reality here? Let's go see the Foundry and the threads. So let's go and see our threads. Watch the latest. Let's go see the latest ones. Okay, this is my prompt. It's not always this one. The please and all that stuff is added, is provided in addition to the initial prompt that someone provides in the text box you saw. But this is another story. So the user message is enriching the message that you are giving into this text box in the app. Please provide a comprehensive Azure cloud architecture for the following requirement. Design two Azure function apps from different regions that save data to one storage account. Context. This is for a production-ready solution that should allow, okay, and this is, and goes on and on. And the agent starts responding, blah, 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 and it's creating this design document that you saw, this thing, okay? But the beauty of this thing is not just the document, it's the architecture diagram, right? Let's see what's happening next. And here it is. Please generate a diagram based on the architecture design, two Azure function apps from different regions, and the same. If I optimize the prompt, of course, this thing will go to the sky. There is no prompt optimization here. It's very, very minimal, as I said. So the second agent is using Python scripting to create the diagrams. And initially, I try to do this with a code tool, try to provide files to the agent, try to help the agent download the Python packages and install them in the sandbox environment where this agent lives. Remember, it's a sandbox environment. When you uh, when you activate this code interpreter tool, your agents are using it in a sandbox environment, but this sandbox environment doesn't have every package installed. So if you tell the agent, please install this and this and this, they may not be able to do it. And that's a bummer, and that's a limitation, and that's the reality. So after a lot of thinking, I decided to do the following. Hey, we have MCP now. Why not create a third service named MCP? Let's have a look. That's holding all the libraries for Azure, of course, of the diagrams information. Here is a CSV, for example, with all the nodes that are used. I could provide also the PNG icons if I wanted to, but it's not needed. The Azure nodes in JSON. So now, instead of using an agent in OpenAI, trying to run code, consuming tokens, the backend for the diagram creation is just communicating with my MCP, which MCP is the magician, is the know all magical sphere, and it helps this backend, this agent, just create the correct script. That's it. It doesn't even need to run the script. It knows before it is published that it is correct. Some observations from the previous deployment where we're using cloud. We had syntax errors, double S's for some reason. I don't know why. For some reason, some resources, for example, function apps, had two S's at the end or three S's at the end. There were ways to fix it with regex expressions and the cleaning up and all, but this is not the correct way to do it. Here is the solution. It's not always about AI. It's about what the tools offer, how you're using them. So instead of take everything there up and make it work and try to make it work and disappoint yourself and your wallet, just don't do it. Use something else. Use MCP, for example. MCP is here to publish tools and make our agents smarter, show them the way. Hey, where are you going? Here is the correct one. So this MCP thing does a lot of stuff. That's true. Let's look at them. So we have a very peaceful backend right now, okay? And we are firing our request. And it's gone. It starts to get alive, right? Creating the API calls to Azure AI Foundry. The first agent is already writing our design documents, which is almost excellent. And there it goes. Now we started working the diagram. Where did you know that? I saw some icons that, you know, let's see what happens. I think it's ready. So here is the important stuff. Watch this. Validation score 100 out of 100. No AI agent could achieve that. We had some 85s with a lot of pain and sweat, but never 100% validation. And here it is, our nice design document. DNS load balancing, Azure SQL and Azure Data Lake, and a very, very nice diagram. Huh? And imagine providing here a correctly stated prompt. For example, color different regions with different boxes. Let's save it. Okay. Um, or or optimize the other prompts, the prompts that give power to our agents. Here, your Python diagram generated. Give a cloud architecture, generate only a valid Python code block using the diagrams package. Do not include explanations or markdown. Your response must be executable Python code to generate a diagram with Azure component. That's it. That's it. Let's refresh and see which threads we used. Here it is. Architect AI MCP diagram agent. What's this prompt? It's not a, it's a very long prompt and it needs optimization, of course, because I'm telling the agent exactly where to find everything. So the agent ultimately provides with a response. It has, of course, code interpreter tool enabled, but it has a guide on its side, and that guide is the MCP. You can see here that we have a failure. Cannot import name data lake from diagrams Azure storage. Why? Why? Let's see why. Data lake, right? Data lake. Oh, I'm sorry. Where is that thing, the data lake? Let's go here and have a look. Data lake. Data lake doesn't seem to be in the storage. But let's be sure. Let's be sure. Data lake storage, data lake storage. data lake, data lake. Let's go find it. Lake, data lake analytics, data lake store Gen 1, Gen 2, data lake store, data lake. You see here the correct data lake. It's in the database family. So what happened here, my friends? Initially, our OK agent tried to create a diagram, and it thought that the data lake icon or PNG lives into the diagram's Azure storage. We're not blaming it, right? This is what it thought. And you know, in that sandbox environment, it has very limited capabilities, just to be fair. But the MCP took over and did this validation. And it came back and said, okay, you are looking for data lake. No, my friend, your data lake is in the other one we just saw. That's what the MCP does. And then everything is history. The diagram is uploaded to a storage account and it is rendered, as you can see. The details of the new solution are published in Azure Cosmos, and we can save it, of course, if we want to, and then come back and have this saved architecture. This is the one just created. This is the other one I had already there. You can delete them, of course, and you can go back to home. This thing will be published very, very soon. It's a very useful tool, and it's a very, very nice observation on Azure AI agents and how we can make things better. I think we went very, very far regarding time. I don't know if really anyone is here, but I really enjoyed this one. I'm sorry for my frustration earlier, but you know, if something takes so much time to be completed, you start wondering if something else is going on. But anyway, everything checked out, and we were able to see 1.5 project, I could say, end to end. Lessons learned. Azure AI services are very dynamically evolving, and there are breaking changes. So something that you create now, maybe in 4 or 5 or 6 months, it may not work. Be careful there. Uh, follow follow the latest updates on Azure AI and Azure, so you will be able to proactively react in case you have something in production or suddenly you see something is not working as it is expected. Most likely there was a breaking change or a change that really messed things up because we're living in the genesis of AI and Azure AI subsequently, and things will be evolving, and we must follow up. Thank you everyone for being here tonight. Uh, you may have also joined from another time zone, so I really appreciate that. I wish you have a great day, great afternoon, or a great night. I will open now my camera. I didn't have open my camera. I didn't open my camera just to save bandwidth. Again, thank you so much. This video will be published in YouTube, and I will provide the links in LinkedIn and in our group. Please go and vote for our next event, what you want to explore, and we are looking actively for speakers. It's time, guys and gals, to take the stage. Don't be afraid. We are here to provide a safe space for everyone to hear you, hear your voice, hear your ideas, discuss with you, and see yourself as our future leaders, our future guides, our future innovators. So my offer is this one: use our group to cultivate your skills and be exposed. It's a good thing to be exposed and um, see how the community reacts to this exposure. It's really amazing, and people will always surprise you with positivity, especially into our practice. I believe in information technology more than it's more than just a job, and knowledge is to be shared. Thank you so much, everyone. Have a great day, have a great afternoon, and have a great night. Bye bye.